Okay, question 7. A diagram below shows a sketch of the existing gas pipe that runs to and from T Gwyn. It also shows a proposed 180-metre gas pipe which is to be laid to provide gas to Caernarfon. The proposed pipe bisects the angle formed by the existing pipes at T Gwyn. So complete the scale drawing below to show the proposed pipe. You must use a pair of compasses to construct the angle bisector. Now I don't have a compass on my iPad, so I can't do this question properly. But to bisect, you're going to need to put your compass point here and then draw an arc that goes like this. Then put your compass on either end where it crosses these two lines. Don't stretch it out, keep it the same width, and make 2 little marks up here. Then with your ruler, you're going to need to join from there, go through that point. Now it's told you it needs to be 180 centimeters, 180 meters, which they've told you is 1 centimeter. So that line needs to be 9 centimeters. Obviously, mine does not look like 9 centimeters, but it's going to need to be 9 centimeters long. So it should look something like that, but do it with a compass. Right, question 7. Ysgol Isa and Ysgol Caerwen are 2 very different high schools. One school is large and is in a rural area. The other is a small school in a town. The town in which the small school is situated has many traffic-free cycle routes. So all the pupils in year 7 to 9 were surveyed in both of these schools. They were asked the following questions. Do you cycle to school? Yes or no? If you answered no, would you like to cycle to school? Yes or no? So the results are displayed in the graph shown below. So the white is others, so the grey is would like to cycle, and the black is that they already cycle. So it's comparing 2 schools. First question. So in which school and year group has approximately equal split between the 3 categories? So it's got to have an even split of all 3. So all 3 have to be even. So it looks like this is probably the one. So all of those 3 lengths, oh, you can't even see that colour. So all those 3 lengths, can't see that colour either. All those 3 lengths are the same. So it's going to be Ysgol Caerwen and it's going to be year 10. So it's Ysgol Caerwen and year 10. Circle either true or false for each of the following statements. There are definitely more pupils in Ysgol Isa who cycle to school than Ysgol Caerwen. I don't think it told us how many pupils in each school. So based on percentages, you can't assume that just because these ones are bigger or smaller, that there's more people in each school. This one school could have 1 million students. The other school could only have 10. We haven't been given that information, so we can't assume that. So we'll have to be false for that one. Next one. Both schools have pupils in each year group with no interest in cycling to school. So that would be the other section. Each one has an other, so therefore, yeah, that's true. So each one has a white space, so that's going to be true. Questions asked were bias. Do you cycle to school? That's not a leading question, so it's not biased. If you answered no, would you like to cycle to school? That's not persuading them to answer yes or no, so they're definitely not biased. Oh, so that's false then, not true, isn't it? Sorry. So the questions asked were biased. So no, they're not biased, so got to circle false. Approximately 20% of the pupils surveyed in Ysgol Caerwen cycle to school. Approximately means like an average, about guess. So it's around 20% cycled to school. So Caerwen is this one. So we want is all the black 20%, or if I averaged them out, would they be 20%? So 20% hit here. If I put this down there, it would probably equal 20%. So yeah, they average out about 20%. So I'm going to say true. Is it more likely that Ysgol Isa is the small school situated in a town? So if you were in a small school in a town, you would probably cycle to school a bit more. So you would have more black. So they do have more black in the school. So yeah, I'd probably say they were the smaller school. Not 100% certain, but they only say is it likely. So yeah, I'd say that's likely that they are the small school situated in a town. Right, in January 2011, there are 1,200 miles of national cycle network routes in Wales. In January 2016, there were 1,400 miles of national cycle networks routes in Wales. Number of miles in Wales will continue to increase by the same number each year. How many miles would there be in 2018? So, difference between them at the moment. So in 2011, there is 1,200 miles. In 2016, there's 1,400. So that's a difference of 5 years. And that has increased by 200 miles. So each year goes up by the same amount. So to find out how much it goes up each year, we can do that 200, not 2,000. So we can do that 200 divided by the 5 to go see how much it increases each year. So that's an increase of 40. So how many 5s go into 20? Add a 0. So each year is going up by 40. So we want in 2018. So in 2016 is 1,400. In 2017, add a 40. 1,440. 2018, add an extra 40 to get 1,480. So that is my answer. Why is your answer in I unlikely to be accurate estimate for the number of miles? It's not really, probably not going to go by the same amount each year, so it probably won't increase by the same amount each year. So it's very unlikely that it'd be the exact same amount each year. Things would change, it might get even smaller sometimes. Right, next one. William owns and runs dog kennels. The cost depends on the number of dogs in the kennels. The running costs for one day are shown on the graph. So this is 1 day, number of dogs along the bottom, and we got the cost along the side. So, first question, why does a graph not pass through 0, 0? So they want to know, why doesn't it start here? Well, with anything that they charge you for money, like electric or even putting your dog in a kennel, there'll always be a fixed charge. That means no matter how long your dog stays in there, no matter how much they're asking, how many days, there's always going to be a fixed charge to put your dog in that kennel. So it's because there's a fixed charge of about £10, I think that is about £10. Right, what is the increase in the daily running cost for each additional dog that is kept in the kennel? So, to find the increase, basically they want how is this going up? Okay, and when line's going up, that's basically they want to know how steep something is. So to find how steep a line is, you're going to need to work out the gradient. Now the gradient is the steepness. It is worked out by doing a change in your y value divided by your change in your x value. So pick two values on there, pick 2 points, easy values, not ones that are out of the way. Like I wouldn't pick this point because that's hard to read. I would pick a point that's in the corner of one of the lines, like this point here is quite an easy one because that's 10 and 50, and this point here is quite easy because that's 60 and 250. So this is my y, this is my x. So my y's are 250 here and 50 down there, and my x's are 60 and 10. So I want the change in y, so I'm going to do 50, 250 and 50, and my change in x, 60 and 10. That's how you find the gradient of a straight line. So, like I said, so change in y is going to be 250, take away my 50, divided by the 60, take away the 10. So 250 take away 50 is 200, 60 take away 10 gives me 50, 200 divided by 50, so zeros can cross off, so 20 divided by 5 gives me 4. So the gradient is 4, so it's got an increase of £4. So it's going at a steady pace of £4. So Frida also runs dog kennels. and the cost of keeping 20 of her dogs in a kennel for 1 day is £130. She knows that the number of dogs increases, the overall cost increases at the same rate as Williams, so if they've got the same gradient, that means they're going to be parallel. We've got to display this information graph, so we've got to plot her graph. So what they've told us is that 20 dogs, 130. So plot that point and then do a parallel line. So 20 dogs, so I would go up from 20 dogs, cost her 130, so it's 100, 110, 120, 130 goes about there. So that line needs to be parallel. I'm sorry if this is not going to be parallel. Ooh. Oh, that's parallel. That's good. Right, so that's going to be her line, because 20 dogs is 130, cross there is 130, I'm just about. Cross there is 130, and those two lines are parallel. Same distance each time, same distance, same distance. Parallel lines, they never meet. Same distance. So that's that question. The bottom bit is find the cost of keeping 30 dogs in hers. So we need to go cross up to hers from 30. So we got to go up from 30 to her line. And we need to read, oh gosh, that's a wobbly one. Need to read across. So it goes 150, 60, so I'd say about that's 170. I'm going to pretend that's on the line there. So that's about 170. Okay, so it's all about straight lines. Okay, next one. Marianian, how are you saying that name? Window cleaning business is no job too small. All you have to do is email her. So she's a window cleaner. From Monday to Friday, she records how long she spends cleaning windows for each of his customers. Oh, that's a man's name. Okay. He draws a cumulative frequency diagram to display the findings. So it's a nice cumulative frequency diagram immediately. That needs to be a curve, not a straight line. That's probably going to be a bit of a question in a minute. So what we're going to do. So we've got to use a cumulative frequency diagram to find the median and interquartile range to the times of his. Right, the median is the middle. Cumulative frequency is a run-in total. So that means they keep adding up their frequency each time. So therefore there's a maximum of 120 people. Median would be the middle. So half of that is 60. So I need to go across from 60 and read down. Oop. Oh god. Across from 60, read down 15, 16, 17. I'd say the median there is 17. Okay, so you're going to go across at 60 because that's the median here, and then you're going to read down. Interquartile range. Now to find interquartile range is you do the upper quartile, take away the lower quartile. Now think quartile, that's quarters. Lower quartile is 1 quarter, upper quartile is 3 quarters. So I do the lower quartile and then the upper quartile. So lower quartile is 1 quarter. So 1 quarter of 120 is going to be 30. So I need to go across, you can basically half the median, so go half of 60 is 30, so go across from 30 and read down. I'd say that's 14. So I'm going to say the lower quartile there is 14. And the upper, so I need 3 quarters of 120, which is 90. So I go across here at 90 and read down. Oh dear. Oh man, it's going wobbly. I'd say that's 19. So I'm using the bottom numbers for all these. So 19, take away the 4, because it's interquartile range, it's a range. So 19 take away 4 gives me 5. Oh, what have I done? I'm writing a pen. Interquartile range is 5 minutes. So she looks back at his raw data. He finds that the median is actually 17 minutes and 30 seconds. So we said it was 17 from his information. It's actually 17 minutes and 30 seconds. Why is there a difference between the median from his cumulative frequency diagram and the actual median from his raw data? As I said at the very beginning, that should not be joined up with a ruler. Okay, don't join up cumulative frequency up with a ruler. So what he should have done is he should not use a ruler to join his points. It needs to be a curve. Cumulative frequency needs to be a curve. Okay, Marion is looking at the time it took to clean individual customers' windows. To find the number of customers whose windows took between 10 and 15 minutes to clean. So between 10 and 15, we need the number of people. Between 10 and 15, we already know oh no, we haven't. We don't know 15. So between 10, so how many is that? 1, 2, 3, 4, 5, 6, and then that's 10. Oh, that's not a straight line, is it? But don't worry. And 15. So go across there. 1, 2, 3, 4, 5. So say that's 34. And I'd say that's about 12 there. So we want how many people in between there. So I want the difference between 34 and 12, which is 22. So I went from 10 and 15, read across. That's 30 and 12, and she wants just those people. So that's going to be 22. Okay, so Marion thinks that for approximately 80% of his customers, he cleaned their windows in less than 20 minutes. Is he correct? You gotta show your workings out. So if there was 120 people, he thinks that he's done 80% of those in less than 20 minutes. So 80% of 120, well, 10% is 12. So we go times that by 8 to get 80%, which is 96. So we're looking for 96. Let's use his graph. So how many in less than 20? So go from 20. There's going to be a lot of lines all over this. Go from 20 and go up. Oh, it's the first one from 100. So it goes up in 2, so it's going to be 102, which is not 96. So let's say less than 20 is 102. Well, no, 102 is more than 96. So it's actually not 80%. So I've got 102 instead of 96. So that's what you need for that. Right, next one. This looks like a long one. So Megan Pugh's electricity bill is shown below. It covers the period May, June and July 2017. Megan Pugh, 203 Stride. We don't need to know her address. Why they include address? So there's a previous meter readings, current meter readings, and then they've worked that out. So they've taken those two away to get this one. Charge for electricity. So they've used the full 50, 20p each to get the 90. 3 months standing charge. Again, like I said earlier, standing charge is a fixed rate, so they've had $7.60 at the end every month, no matter how much electricity you use. Total charges, then they do VAT at 5%, and they get the total amount. Not too hard. So August, the charge for electricity was increased by 5%. So what is the increased cost per unit of electricity? So how much was it before? It was 20p. We got to increase 20p by 5%. So we're going to need 5% of 20p. Well, 1% is going to be 0.2. Times that by 5. Well, 2 5s are 10, so it's going to be 1p. So it's only increased by 1p, 20p. Add the 1p, gives me 21p. Megan wants to calculate her next 3 monthly electricity bills. She knows the following. Her meter reading on the 31st of October 2017 was 14,400. Can't even read. The charge per unit for electricity has increased by 5% since her last bill. Standing charge has increased by 20p per month since her last bill. It's not very nice. VAT remains at 5%. She has $470 in her bank. After paying the bill, can she afford a new washing machine for £330? This is 9 marks. Wow. Okay, first thing we're going to need to do, exactly what they done, is we need to know the number of units that she has used. So from her last bill, we know that there was 390 left, and then it's gone up to 14,400. Oh gosh. So the electricity she's used. Good job it's not OCD though. Electricity used. So we've got the 14,400 that's in it at the end. Take away a previous one, which is 13,900, leaves us with 500 units of electricity. Now the charge, they told us it went up by 5%, but we knew that from previous question. We've worked that out already. It was 21p. So charge per electric is going to be the 500 times the 21p. Won't take you long to do 21 times 5. I want me to do it over here, I don't mind. So we got 21 times 5. 5 times 1 is 5. 5 2s are 10, so it's going to be 105. So that's going to cost a 105. We need a standing charge now. And they said it increased, didn't they? Standing charge. So the 3 months, what was it before? It was 760 and it's gone up by 20p. So 760, so that by that 760, add the 20p, gives us 780. So times that by 780, you could write that out 3 times. You could do it how I've done it over here, but I'm going to do 7.8 times 3. 3 8's 24. 3 7's 21. Add the 2, so it's 23. So when I put the 0 on, decimal there, so that's going to be £23.40. So we know that's her electric cost, that's her standing charge. So let's work out her total cost. We haven't added VAT yet, but we'll do that now. Total cost, got £105 plus the 23.40. You can write those underneath each other to add those, but it's 128.40. Now we need VAT. Did they say that stayed the same? VAT remains at 5%. So VAT at 5%. So we need 5% of 12840. Right, okay, we need 1%. It's going to be, I'll divide it by 100, which is 1.284. And we need 5 of those, so times that by 5. 4 5's 20. 5 8's 40. Add the 2, 42. 5 2's 10. Add the 4, 14. 5 1's 5. Add the 1, 6. So that's £6.42 for VAT. So let me write that in. VAT is at £6.42. So total charged is going to be 128.40. Add that VAT, 642. So it's 2 8 there, 4 caramel 1 3 1. So that's how much she is going to be charged. That's her bill. Not quite finished yet. She wants to buy a washing machine. How much has she got? She's got, how much money she got? I can't see it. Oh, 470. So she got 470 in a bank, and the washing machine is 330. So let's say we're gonna do, so she has 470, take away that 13482, so be invisible zeros after here. Ooh, we're gonna have to go all the way back to the 7 to borrow, so 7 becomes a 6, then that would become a 10, but that's now a 9, that's now a 9, so this is our 10. The 10 take away 2, which is 8, 9 8's 1, decimal straight down, 9 4 5, 6 take away 3 is 3, 4 take away 1, which is 3, so she has that much left. Ooh, she can just about afford the washing machine, so the washing machine is 330, so she'll have £5.15 change. So yes, she can buy the washing machine. Yeah, go for it, buy it, treat yourself to a washing machine. Right, got a lot for that question. So there we go. Right, next one. Question 12. So there's a lot of box plots going on here. Like our cumulative frequency of box plots, they're related. So Lena has 3 apple trees in her garden. Oh, lovely. She has 1 gala apple tree, 1 orange pimpin tree, and 1 pink lady. Oh, galas are better. So she picks 50 apples from each of the 3 trees. She records the width of each apple as shown. Oh my gosh, she's recording the widths of apples, okay? Construct the box and whisker diagram for the widths of the apples. Oh, she constructs them. So those are the gala trees. So with a box plot, there's a bit of information you need to know. This whisker here is the maximum. So we can see, I'm just going to write this on the gala one. So we can see here the maximum gala one is 1 to 83 there. This whisker is the minimum. So the smallest width of the gala apple is 42. The line in the middle, if you can guess it, is the median. In the middle is your median. Like from cumulative frequency, this one is our upper quartile, and this one is our lower quartile. And each bit here, so this is 25%, this is 25%, this is 25%, so you can see there's a lot of big ones in gala, and then this is 25%. Okay, so that's the same thing for each one of those. Probably got to compare each one now. So complete the following statements. Apples from something tree have the least medium width. So the medium width recorded is, so we'll know where the medium is. Let me highlight them all in blue. So that's a median, and that's medium. But there. So luckily they've got all the same from 13 to 19. It's all symmetrical. So we can see the one furthest down is the orange pimpin. So we can say apples from the orange, can't spell orange, orange pimpin. Oh, I didn't see what it was. So the median is 50, oh gosh, 1, 2, 3, 4, 5, 6, 7, 57 millimeters. Oh, 57, not 7. 57. The range of the widths of apples recorded for gala apples is, right, it's just asked for the range, not interquartile, so that means the biggest. So range is going to be your max, biggest, take away your smallest, your minimum. So we're looking at gala, not me yet. Gala apples, so the maximum 81, 2, 3, and the minimum 41, 2. So 83, 42, did I say? 83, take away 42, gives me 41. The something apple tree has apples with the greatest interquartile range. I knew they'd ask us to do that. Interquartile range of the apples recorded on the tree. Right, let's look at the interquartile range for all of it. I mean, you can kind of see which one has got the biggest box, really. So the biggest box, that means this distance. You could work it out, but I mean, I can kind of see it's this bottom one. That's got the biggest box. But if you want to work all of them out, that's fine. But the biggest box one is this one, I'd say. That's 79. That there is 46. So, what did I say it was? 79, 46, so that's 33. So that was the pink lady. And it is 33. Which tree has a high proportion of larger apples? So we want the biggest upper quartile, 20%. So basically this bit has got to be the biggest. I feel like it's going to be gala. Yeah. So which has a high proportion of larger apples? You must give a reason for your answer. So we can say gala because the upper quartile is the highest, really, isn't it? So if I look here, upper quartile, yeah, upper quartile is 80, so they've got the highest upper quartile. Gala because it's the biggest upper quartile. Okay, next one. Emilin has a photograph that he wants to enlarge. The diagram of the original photograph has a diagram of the enlargement as shown below. So he's got a lovely photograph of a turtle, and we need to work out the height of the enlarged photograph. So it's given us 2 bits of information. So it's got this is 6, this is 15, and then we've got 4 here, and we need to find this length here. So it's quite a straightforward one. So we go, what do you need to go from 6 to 15? So what do you times 6 by to get 15? So you would times that by 2.5. So to get the height, you're also going to need to times the 4 by 2.5. So we need to do 4 times 2.5. Well, 4 times 2 is 8. Then half of 4 is 2. So 8, add the 2, gives me 10. So the height of the enlarged photograph is 10 centimeters. There we go, and that's the end.